Thank you. I was supposed to start with the same expression of the pictures on the schedule, but you know, well, they are those kind of expressions that come naturally only the first time and then very hard to be repeated. Anyway, talk about ASP.NET Core, which is essentially the new baby, and it's for everyone who is involved in web development, a relevant update. This is an absolute fact. But the question is, and the question that I will try to address and answer as comprehensively as possible this morning, is it relevant? That's okay. Is it an update? And that's okay. Well, it's much more than an update, but is it relevant update for everybody? Migration. ASP.NET Core is essentially about migration in the sense that whether you have today a lot of code running applications, in a word, legacy code, whether you have this, or whether you are considering building from scratch, doing some, to use an American term, a US term, a greenfield development, whether is your scenario, it's still about migration because at best you will be migrating your skills from the existing world of web development, whether it's made of Angular, JavaScript, or server-side skills, whether it's PHP, or even, and that is the most important point, even if you have been an ASP.NET developer in the past, you still are going to migrate your skills towards the new platform, the new infrastructure, the new thing called ASP.NET Core. And this is because, essentially, the new one is completely rebuilt from scratch, with good reasons and with other reasons. So, in summary, this slide offers you a couple of columns with the challenges you must be ready to face and the opportunities that in some way the conference, the ASP.NET Core is going to give you, and conferences are typically going to emphasize. Challenges are MVC only, first and most important point. So this means that if you had in the past exposure to web forms, forget it. There is no, forget it, period. It never happened because there is no support at all for web forms in the new platform. I know this is a fairly debatable point, and the same Microsoft, spent a lot of time looking into ways to make the two things work together. At the end of the day, they reasonably, in my opinion, rightly, in my opinion, decided to just drop it. So MVC only. And the first issue on the way to migration you must be ready to face or must be aware of is you must migrate your skills regardless towards MVC. And the distance, the logical gap between web forms and the MVC way of creating the web, well, this is a gap that we had, however, probably 6 years at least to make, because MVC was introduced on the ASP.NET Stack around 2008, so it's 8 years later at least, less if we consider the very first officially released version, but it's been a few years already. MVC is the way to go, period. At the moment, also, C# is the only way to go. So if you have and that's pretty common actually, web forms on VBNet, forget it. Well, the roadmap says that at some point, Visual Basic will join the group, will be part of the new exciting world, but for the time being, it is not the case. MVC, C# only, a new API. the reason, the technical reason for dropping web forms is not just how we want to make harder your life. We are Microsoft, we are a big company, we are a big vendor, and we love to hurt you. We want to torture you. No, that was not the real thing that happened. Dropping web forms was mostly due to removing a lot of intricacies, a lot of tight coupling and tight dependencies that have established in sort of 15 years of ASP.NET between the runtime of ASP.NET and, well, I was going to say the web server. One web server, IIS. So at the moment, there is a magical word called integrated pipeline, that not that many years ago was presented to the world as the greatest success, the greatest achievement from the web team at Microsoft. Exactly that concept today is totally being burned out, removed, dropped, forgot about, because the world changed, because the business changed, because there are always new challenges to be caught. So new API, new hosting model, new everything, and more importantly, no longer IIS centrism. It means that the new ASP.NET is then able to work on whatever web server, present, past, future, that offers some level of integration with the new API. And the new level of integration is now no longer a trade secret, but is an open contract, is an open interface that is free for vendors of server systems to work with. Final point, final challenge, the .NET framework. We've been used to consider, to think of ASP.NET as one thing with the .NET framework. In many ways, the ASP dot before the net, or the ASP before the .NET, were just, one extra word to qualify the segment of the .NET framework that was specific in use for web development. Now is going to be, also this aspect is going to be quite different, in the sense that it's not guaranteed that we have the full .NET framework available. We have to choose, and we have essentially two options, two main options. We can write ASP.NET Core applications and target the full .NET framework, the one we know today and we have used for many years, and or a new one, smaller, with ideally inside all and only the features that have proven over the years to be structurally important, strategic to web development. It's a smaller framework called .NET Core with one key benefit that essentially allows us to transition to the second column, X platform. So if you choose to target in your web development on the ASP.NET Core platform the .NET Core framework instead of the full framework, the first key opportunity, and that's absolutely new and unbelievable in some regards, you gain is the ability to run your code, to host your code on whatever platform that the core infrastructure supports, specifically Linux and Mac. And the moment in which you start as a Microsoft team of architects thinking of being cross-platform, rewriting the .NET framework from scratch, the entire API you get gets improved, is repainted, gets a facelift. So improved API. So if you target the .NET Core framework, in a way you will be able to do essentially the same things or nearly the same things you were used to do with the old familiar .NET framework, except that the API in some places, in some points, is not exactly the same. It's conceptually the same, but technically, syntactically, not the same. But overall, as far as the web is concerned, the MVC paradigm, the way of writing and thinking web applications is essentially the same with an improved API, and that is the #1 business reason, in my opinion, to seriously consider ASP.NET Core is the total control you gain over the runtime pipeline. And it means that you can really decide how much code has to get in the middle, get in the way for each and every of the requests that for your application come into the system. It's nice to think that in MVC, that today, ASP.NET MVC, there is many CPU cycles consumed. I was going to say wasted, but let's say consumed, in order to process a single request. So the moment in which your code kicks in and starts doing the work it was written for, a lot has happened already, and that happens for each and every request. Now, is this going to be a problem? I don't know. That is a question, a kind of question that cannot have a general answer. That is a question that everyone in his own team, given his own set of customers, can answer. So you decide, essentially. But I'm here just to help you in making this kind of decisions. This is what we have today, a picture that represents the schema of the current architecture, .NET architecture for web solutions. There is IIS at the bottom, and on top of that, there is the notorious, infamous, but still pretty familiar system.web assembly, which has been identified recently, well, has the root of all evil, which is not. I mean, I love it. I built my house. I bought my house. I grew up a family with the revenues coming from writing about system.web. So I love system.web. It's an old friend that, for me, it's still an old friend. But anyway, he's going to pass away. And on top of that, at the moment, we have web forms, and MVC has two programming paradigms that heavily rely on the machinery on system web, and system web in turn relies on the thing called integrated pipeline on the services of IIS. So there is no clear boundary set between IIS and system web. And the interesting thing is that that was precisely an architectural goal for a few years. It is no longer an architectural goal. So breaking this kind of tight integration is now the real architectural goal that Microsoft is trying to achieve with .NET Core. Another interesting thing is Web API, so the part on the extreme of the slide. At some point in recent years, a new buzzword called OWIN started getting exposure and becoming popular. Open Windows Interface. It is an attempt to define a public contract between a web server and a generation of new software. In a way, OWIN represents an interface, public, common, open source interface to initialize web code running on compatible, compliant servers. And Microsoft, in particular, used OWIN to build up Web API. Web API is I have contrasted feelings about Web API. I like the idea, but I don't like at all the implementation, and probably I never used Web API, if not in very special and particular situations. But at the same time, I can hardly think of a different way in which it could have been done the time being. So this is the point that makes me having such contrasted feeling about Web API. The point is, Web API was devised to be the engine that allows developers to create extremely dedicated, focused web servers. So you need to have just a set of endpoints that return JSON data with no need of generating HTML. Fine. Web API is a pipeline, is an environment that sits on top of a web server and allows you to just focus on returning objects, serialized objects, just data instead of HTML views. Great. And it was built on top of the OWin interface for openness. And one of the nice features, just due to the OWin interface, is that you can now host the Web API runtime, say on a console application, or perhaps on a Windows service, and still have an HTTP interface to call without all of the extra burden represented by a web server, and specifically IIS. But at the end of the day, because of system web being so tightly integrated with IIS, and because Web API was still something that had to run except Windows services or console on IIS, you still need to have a web app that hosts the Web API runtime. And that web app had to be either web forms or MVC. And when you do this, and by the way, this is a pattern, a development pattern that has been widely advertised and marketed as the way to go, well, that has a clear little issue. It just doubles the amount of memory and the amount of pipelines you have to load for and process for each and every request. Because Web API has its own pipeline, but in the scenarios in which you host Web API in an MVC or web forms application, even though that is simply the host, you have the pipeline hard-coded in system web plus the pipeline of Web API. And curiously, the pipeline of Web API, the classes called controller, the concepts like action, result, action, method, and similar to MVC, they are similar in name, but the namespace is different, the assemblies are different, the pipeline is different, and both run at the same time, making pretty expensive the cost of processing a request. So, oh, no, the culprit is system web. System web was, okay, resulting from the idea of tightly integrating it with IIS, but system web alone with web forms on top of that, or perhaps with the sole MVC on top of that, is not that bad in terms of performance. Anyway, we are moving from this to a much slimmer architecture in which there is a web server, and notice, it's no longer IIS, it's web server. On top of that, we have a layer that I generically labeled as integration, and that is how you configure the web server, and you do that depending on the plugin mechanisms supported by the specific web server, so it would be probably an HTTP module in IIS and something else in Apache, for example. And the integration layer you put on top of the web server exposes an OWin interface for the new ASP.NET Core to plug in and expose towards the developer an MVC way of coding. And the MVC now is represented by a totally new pipeline. So it is no longer the system web-based pipeline. It is no longer, it is not even the Web API brand new pipeline. It's yet another new pipeline that tries to get the best from the system web experience and the Web API experience. And in this context, Web API just disappears. It disappears because it has no sense. If the pipeline is tailor-made, Web API has no sense at all. There is no need for having two types of controllers, one for returning HTML and one for returning JSON. One better controller environment is the way to go, and that is precisely what they have done. There is no longer, I mean, Web API is still a nickname you find in some documentation, and you will hear around for quite a bit of time as ASP.NET Core gets popular and popular, but at the end of the day, it is still about having a single new central controller class that can serve in different ways, HTML and JSON or data requests. At the same time, the new controller class, the new MVC paradigm, no longer requires that the controller class is a class with a specific and well-known inheritance chain. The controller class is just any class. It's a POCO, plain old CLR class, that just returns, generates some data, and injects that data into the response stream. So changes, tight coupling between ASP.NET and IIS, presented as a big win only a few years ago, gone. Platform dependence, strategic move, gone. Open, no longer Windows only. System web, that is the Hayville, devised back. Well, system web was devised in 1997. The first time I heard about that was 1999 from a man who was not even wearing yet red shirts. So there was a time in which Scott Guthrie wasn't wearing red T-shirts. He was wearing, regular shirts of any color, blue, gray, green, not red, no polo shirts, nothing like that. So, well, time is crazy sometimes. So, Scott Guthrie presented. It was a very young Scott Guthrie. He was nobody. I was the star. He was nobody at the time, and well, incredible. It's been in the thoughts of Scott Guthrie since 1997, system web, so it's pretty old. So it was about time that it was completely rewritten, and in this case in particularly took apart. And when they tried to take system web apart, well, they had to change a lot of things. Let's take a look at what they really changed. So this is now in Visual Studio 2015. This is a sample application, just an hello world application that has a few significantly different things. Let me see if I can use. If I'm able to use the magnifier here, probably yes. So there are a couple things to notice. This is the project, the new ASP.NET Core project. Yes, there is a web config there at the bottom, as usual, I would say, except that it is there only to please IIS. So you don't need that if you are going to host the application elsewhere outside IIS. So the only content you find in that web config is the line that registers an HTTP module to teach IIS how to support OWIN and the core runtime. There is nothing more than that in web config. So all of the other things we were expected to find in web config have been moved elsewhere. And I'm talking about the configuration for authentication, for error handling, connection strings, or perhaps any global data that your application needs to work with. Then there are a couple of other items there, startup.c# and myappsettings.json. Myappsettings.json is one possible way to store whatever global data your application needs to have. So things like connection strings, for example. But along with connection strings, you can find there titles, constant strings, whatever piece of data in your application is constant. And then startup.c#. That is the new place where most of the initialization work takes place. Another significant missing piece of the current jigsaw you cannot recognize there is global ASX. Global ASX was the markup from which the system was automatically generating a code behind class to start up in a global way the first instance of the application. So global ASX generates a class today that inherits from HTTP application, and HTTP application is the base class for every running ASP.NET app. The same concepts and the same initialization work has been moved into startup, and startup follows an all-win kind of vision of the world. So let's take a look at the content we find in startup C#. There are, in addition to the constructor, this class must have, that's kind of mandatory. It's mandatory, but at the same time, the code still compiles, even though configure services and configure are not there. So, I mean, as you can see, there is no interface that the compiler can validate and stop you to say, look, this startup class is not going to work. So there are many different ways in which one can write a startup class. But at the end of the day, if the runtime doesn't find configure and unconfigure services, well, you are going to have some problems. But it's runtime problems, not problems that a compiler can detect. Configure services and configure are both methods called by the runtime. You use the first, configure services, to essentially list all of the runtime services your application needs to have available. And as you can see, configure services gets from the system injected an iService collection, which is a new type that represents a collection of services. In a way, configure services is the place where you decide how many pieces of logic, of globally available logic, you need to have in your middleware. So there you configure the pipeline and you decide how many checks and filters you want to have along the way from the moment in which the request comes in through the HTTP listener into the chain and the moment in which your code manipulates that. Today, honestly, and as weird as it may sound, we have no way to remove all of the steps along the way. Even in, I don't know, web forms, when we define an ASPX file and then we write code in the method page load, we believe that code is invoked at the very beginning of the request. It never happens that way. If we want to run some code at the very beginning of the processing of a request, we need to go back to global ASX and globally write a handler for the begin request method, except that the begin request at the global ASX level is code that runs for each and every request, so we have to filter out. And so if we rely on page load, it's probably the final step of the pipeline in which our code is invoked, and we have a little control over all of the other steps, including authentication, including session management, output caching, and custom steps. They are there, and they remain there. Now here, in ASP.NET Core, we essentially start with a totally empty pipeline in which we don't even have support for MVC and for classic ASP.NET programming. In fact, if you are going to write a web front end that is MVC based, you have to add in this configure services method services.addMVC. So the interesting thing is that without services add MVC, you are no way able to deal with controllers, classes, actions, methods, attributes, views, and this or that. And in this case, the question is, okay, but if I forgot to add and call in explicitly MVC, what is the way in which I can give life to this application? And the answer is here. There is commented code here, but say this app parameter, which is injected into the configure method, that application builder, that represents essentially the application, the running application. And it's the environment that runs the application. And in configure at the end, we can imagine to comment out all of this. And if we limit to have this 3 lines of code, app.run, and we pass a piece of code, we pass a lambda expression, and that's it. So whatever code we can place there in the body of the lambda, that runs as soon as the startup of the request has been completed. So the request comes in, and because you configured no additional service, it goes straight to taking into account the configuration and runs your code. So if you place there, instead of the context.response write async, if you there place some ifs, some logic that checks, I don't know, the query string, but accessing directly the request stream, so context.request, for example, gives you access to the query string, the form, cookies, headers, URL, whatever. So accessing directly the HTTP context of the request, if your logic is simple enough that that's sufficient for deciding what to do, you can do whatever right from there. So the controller makes not necessarily sense. It's your code that runs there, and you can write back to the response stream from there, as we're doing in this example, and whatever you write is sent back to the caller. There, in this case, there is nothing in the middle. It's just the request, the necessary runtime environment, and your code. There is even no routing at all. There is just nothing else. So this is what I mean when I said total control over the environment. It's just about what you really need to have. And this is essentially the infrastructure that makes ASP.NET Core in some way close, conceptually close to a thing called, I think, Node.js maybe. Now, beyond this, let's try to consider a more common business scenario. You want to build up a full web application in much the same way you have a web forms application today or an MVC application today. You need to do quite a bit of work to configure the environment. And this is a kind of work that we never have done before. Because today, with 2013 or even 2015, when we create a traditional ASP.NET web application, we are served by Visual Studio, a project in which everything has been plugged in through automatic scripted NuGet calls, and we find already referenced in the project all the MVC, Razor, DLLs, and we can rely on, for example, for static files, images, CSS files, script files, on the services built in IIS. Because we cannot rely anymore, we don't want to rely anymore on a specific, on the specific services of a specific IIS in this context, we have to programmatically and fluently define the runtime environment for our requests. So here is what we need to do. So at the very, very minimum, we must configure the MVC service in configure services, and then in configure, we add parameters. We essentially configure all of the services we have linked at the previous step. The configure method receives a few, is injected actually, a few parameters from the system, the application, the hosting environment, and even a logger factory. not a factory class for whatever logging infrastructure we want to leverage. So in this case, as an example, we are using the console logging system through a predefined add console method. The environment gives us a way to define different strategies for error handling depending that we are in a development staging or we are in production. And you see that use exception handler and then the URL, that is the new way essentially of dealing with custom error handling. So there is no more anything like, define the error page for the 500, for the 404, the 403 errors in web config. There is no more the need to redirect to a default page in web config. That's the way in which we do things. We have no longer an application error even handler to possibly define in global SX. All we need to do is defining an endpoint that receives all of the unhandled exceptions, and then in home error, well, then it's up to you to figure out in some way what was the last exception, and then redirect the user, or presenting the user in some way that nice UI with error messages, and possibly and ideally with links to the places, the endpoints in the application where the user can go to resume safely the session. And of course, through exception handler, through the URL there, you can even do any special logging activity that you plan to have done in case of errors. In addition, there is also the logging system there that you can use just to log and trace the activity from many other places. So use exception handler is just in case of unhandled exceptions, but you can still have logging, and that is another level of control. This is another key piece of the jigsaw that is relevant to have to be able to start from where you typically start today. Use static files that enables the runtime environment to serve static files, so CSS, script, images. Without that, trust me, if you put this online, or even if you work with a sample application on the local host, you cannot reference from a Razor view a CSS file, or even without outside Razor as plain HTML, you cannot reference from that server a PNG file, because you say, well, I don't know how to handle this request unless you explicitly enable support for static files. And then if you want to build a realistic MVC application, you need to add routing. And the way in which we add routing, accept the different syntax, this use MVC and then a lambda that defines the dictionary of routes. Well, but the code routes, .map route, the template and whatever, syntax is slightly different, but you can easily recognize from there the code that you have seen in today's application. One final piece of code that is significantly relevant and relevantly different in the core is the configuration. There was this JSON file in the project, and this is a common, not unique, but a common way of dealing with global data. You create a JSON object as plain text. And then you can give this JSON file essentially any sort of interface, any sort of structure, so it could be flat, could be nested, you decide that. And once you have defined this, you have to import the content into the application, and you do that by essentially adding the options, enabling the options capabilities, so how to instruct the pipeline to deal with these things, and then the mapping between the JSON text and the an in-memory instance of a class happens through the configure of T. Global config is your class. It's a class that you create that is essentially one-to-one with the JSON structure. Now, which you write first is probably up to you. It's just like the egg chicken game, before the JSON or before the class, but the two things must go hand in hand. And the system, the runtime, offers the great capability of automatically mapping the content of the JSON file into a newly created instance of this class. So at the end of the day, after this configuration is done, you have a global instance, unique instance, that contains all of the configuration data. The next question is, how can I pass this information to my controllers and to the places in code where I can use that? Here it is. In a controller class, you use the I option of T, and T is the class that contains your JSON serialized configuration, and then you, with a sort of common programming approach, you capture the configuration and save into a private variable and use that in the controller class. And the I option here is possible because of the native support for dependency injection that the entire framework has. So this is another thing that is pretty different compared with the code we have today. And, well, but it's nothing really hard to learn for developers. So in the end, it is whether or not ASP.NET Core is valuable is, so the decisions about that, in my opinion, pass through a couple of situations. One is you and IIS. So if you have problems with IIS, if you feel you have problems, performance problems for the most part, with IIS, and you are, oh, if only I could use Apache server, well, you can now do that. Or if you have some Node.js nostalgia, or you wish to feel like a geek again and use everything from the command line. Another point is you and ASP.NET. If you have troubles with web forms, you are using web forms, and you don't like it, or you are using MVC, and for whatever reason you don't like it, well, no, forget this. Because in this case, you're still having MVC. So if you don't like the MVC paradigm, probably go for PHP. Or for Java server pages. But if you don't like the performance of today's MVC applications, well, in that case, whether you are more SPA guy or a server-side guy, you are essentially having some satisfaction, except that it's not your code that sucks. Well, this said, there's not much else that can be added to ASP.NET. If you're planning a complete rewrite, probably ASP.NET Core is definitely worth a look. Thank you very much for your time.